Hey everyone, I'm back with a new video. It's been almost a week. Now we know a little bit about what are the basic building blocks of neural networks, that is the perceptron, and we also are aware of multiple terms. Let's do some quick revision and then we will understand what are the important factors, how we are compiling a model with the help of Keras. Let's quickly understand the terms which are like first term is input. Input can be defined as a source data which is fed to a network. Each value is fed into one of the neurons in the input layer. Then comes the training set, the set of inputs which the correct outputs are known. The set of inputs for which the correct outputs are known used to train a neural network. Then comes the output. The neural network generates the predictions in the form of the set of real values or Boolean decisions. Each output value is generated by one of the neurons in the output layer. Then the most important term is the neuron or the perceptron. This is the basic unit of the neural network. It accepts an input and generates a prediction. I know these terms may be very simple for most of the audience, but yes, we should know the difference between all the different terms. In some of the terms, there may be a very thin line or a fine line of difference, but we should be clear about it so that none of the terms make us irritated in the next phases. Let's understand the activation functions. I think we have already gone through multiple activations functions like that of the tanh functions, ReLU functions and all. So quickly as a definition, each neuron accepts part of the input and passes it through the activation function. The common activation functions are sigmoid, tanh, and ReLU. We have also gone through the advantage and the disadvantage of the various functions. These actually help or generate the output values within an acceptable range, and their non-linear form is crucial for training of the network. Then the most important part is the weight space. I think you remember if I talk about a perceptron, the input was in the form of like x is equal to wx plus b, where my wx was the dot product. So this w is the weight. So each neuron is given a numeric weight. The weights together with the activation function defines each neuron's output. The neural networks are trained by fine-tuning the weights to discover the optimal set of weights that generate the most accurate prediction. You must also remember that while studying the backpropagation, we were trying to update the weight in each and every iteration. So weight plays a very important role for our end goal. Then we also studied about backpropagation and the forward pass. So if I talk about the simple definition of forward pass, it takes the input, passes them through the network and allows each neuron to react to the fraction of an input. Neurons generate their outputs and pass them to the next layer until eventually the network generates an output. So now we have revised what is an activation function, a weight space, and then the forward pass. Let's little bit deep dive into the forward pass and the backpropagation. So the forward pass is taking the input, it is passing through the network, it is allowing each and every neuron to react to that input, and eventually it gets the weights get updated. Then comes the backpropagation. So in order to discover the optimal weights of the neurons, we perform a backward pass, moving back from the network's prediction to the neurons that generated the prediction. This is called backpropagation. Backpropagation tracks the derivative of the activation functions in each successive neuron to find the weights that brings the loss function to a minimum, which will generate the best prediction. So this is a mathematical process, what is called as gradient descent. I think you remember the example where there was an image and there was three different persons with three different minima points as A, B, C. The person had to reach the local minima. So there were certain possibilities like it can move forward, backward, downward. And also there were certain possibilities like how much step size should he take. So that was the learning rate that we had discussed before. Then comes one of the most important term, which is known as the bias and the variance. Bias is the difference between the average prediction of our model and correct value which we are trying to predict. Model with the high bias pays very little attention to the training data and oversimplifies the model. It always leads to the high error on the training and the test data. Then, variance is the variability of the model prediction for a given data point or a value which tells us the spread of our data. Model with high variance pays a lot of attention to the training data and does not generalize the data which it hasn't seen before. As a result, such model perform very well on training data but has high error on rest of the test data. So there is a trade-off between the bias and the variance that we have to maintain while we actually create a model. Another meaning of a bias is the bias neuron, which is used at every layer of the neural network. The bias neuron holds the number 1 and makes it possible to move the activation function up, down, left and right on the number graph. Then comes the hyperparameter. Hyperparameter is the setting that affects the structure or operation of a neural network. In real deep learning projects, tuning the hyperparameter is the primary way to build a network that provides accurate prediction for a certain problem. Common hyperparameter includes the number of hidden layers, the activation functions, and how many times, that is the epoch training, should be repeated. So now the most important topics like the bias, variance, hyperparameters, we are aware of those topics. Let's move forward with the two main challenges of any type of model. This may be a deep learning model or a machine learning model. The two different challenges are overfitting and underfitting. Now imagine you are having a test data with 100 lines and you're having a training data with 100 lines. Now when we're trying to predict using that training data, you see that there is a 100% accuracy on the training set. That means your model has not learned, but it has memorized the things. This is what is called as overfitting. So it happens when your network is good at learning in the training set, but it's not able to generalize the predictions to additional unseen example. This is characteristics by low bias and high variance. The second problem is that underfitting. Underfitting happens when the neural network is not able to accurately predict for the training set, not to mention for the validation set. This is characterized by high bias and high variance. So very important, low bias and high variance means overfitting, and high bias and high variance, both are high, means underfitting. So there are certain ways or certain steps that we have to follow while we need to overcome the challenges of overfitting and underfitting. So the different steps or the ways to avoid overfitting is that retrain your network, train several networks in parallel with the same structure and different weights, early stopping so that we can train till the point it starts overfitting. Then the most important is the regularization. This will help to decrease the weights and biases and smooth the outputs. Then you can tune the performance. This defines how much you need to regularize the network. Second is that how should you avoid underfitting? You can add the neurons on each layer. This will help to generate complex predictions. You can add more data, that is more training samples. Another important term that we will study today is the dropout, and it is one of the method how we can avoid underfitting. And then dropout mainly means that randomly you're dropping few neurons in every iteration, and then you can decrease the regularization parameter. So this is about how you can avoid overfitting and underfitting. Now let's see the difference between what is a model parameter and what is a hyperparameter. I know we have already discussed about the hyperparameter, but just to reiterate what is the difference between the two. So when we call a model parameter, it is internal to learn your network and is used to make the prediction in a production deep learning model. The objective of the training is to learn the values of the model parameter. But when I talk about hyperparameter, these are the external parameters set by the operator of the neural network. For example, number of iterations of the training, the number of hidden layers, the activation functions, etc. Different values of hyperparameter can have a major impact on the performance of the network. So bias, variance, and then comes overfitting and underfitting. Then what are the different methods how we can help with removing this overfitting and underfitting? Then we should know what is the difference between a simple parameter and a hyperparameter. So I think we have covered all the topics today. Let's move forward to learn the important topic, which is known as the dropout. So dropout actually refers to ignoring the units, that is the neurons, during the training phase of the certain set of neurons which is chosen at random. By ignoring, I mean that these units are not considered during a particular forward or a backward pass. A fully connected layer occupies most of the parameters, and hence neurons develop codependency amongst each and other during the training, which curbs the individual power of each neuron, leading to the overfitting of the training data. In machine learning, regularization is a way to prevent overfitting. Regularization reduces overfitting by adding a penalty to the loss function. By adding this penalty, the model is trained such that it does not learn independent set of feature weights. I think many of you are aware of the logistic regression and also be familiar with the L1, that is the Laplacian, and the L2, which is the Gaussian penalties. So basically it's an approach where we can remove the issue of overfitting. If you can see the diagram, the A diagram is actually saying that when each and every neuron is considered, how your architecture of the neural net looks like. But when I talk about the B diagram, it is like we are actually ignoring some of the neurons, and hence the other neurons is not getting activated. So after dropout, this is how my neural architecture would look like. And dropout, when we consider the neurons, those are always random neurons. So I think we are pretty clear about what dropout is. I'll reiterate one more thing, like at each training stage, individual nodes are either dropped out of a net with the probability of 1 minus p or kept with the probability of p, so that the reduced network is left. Incoming and outgoing edges to the dropout node are also removed. So these are actually the basic terms that you should know before we actually jump into the networks. And also one important thing is that this lectures are totally technical, so it moves very with all the technical terms and all. But until and unless you know the end goal of your statement or end goal of your problem, what do you want to solve with a particular neural network? And when I talk about a problem, it's about the functional statement or the business statement that you try to solve. So in few other lectures, in the further lectures, I'll try to club up technical things with the functional things, so that after merging of both, you can find what is the importance of the end-to-end story. So there would be a functional statement or a business problem statement that will get converted into a technical statement, that will get converted into a DS statement. Then we will be solving that particular problem with the help of neural networks or maybe classical machine learning, and then how that output can be used by the business and what all advantages the business will find over the older techniques or the classical techniques that that particular business used to do. So this is very important as a DS. It is not only the technical things that we should know, it is always the functional aspect of it. So now I'll just give a little bit background how Keras work. So if I talk about the core architecture of the Keras, it is like it helps us to organize and design the layers. There are two ways of composing the models. Sequential and the functional are two ways to build Keras models. Sequential model is simplest type of model, a linear stock of layers. The sequential API allows you to create models layer by layer for most of the problems. It is limited in that it does not allow you to create models that share the layers or have multiple inputs or outputs. So if you can see this particular first set of code where I'm just defining a sequential function, which is the API in Keras, and then you are just adding the different layers one by one. So first network or the first layer is having one dense layer, and then there's an activation function, and then we are using the dropout. Then we are also using again a dense function where there is hidden layers, and then an activation function and a dropout, and then we are having the output, and at the output we are using the activation function as the softmask function. So this structure is exactly like a stack or a queue, and therefore we can say it is a combination of a linear pipeline in the form of layers. The second one is the functional one. If we need to build arbitrary graph of layers, Keras functional API can do that for us. The functional API allows you to create the models that have a lot more flexibility, as you can easily define the models where layers connect to more than just one previous or the next layers. In fact, you can connect the layers to any other layer. As a result of creating complex networks such as the Siamese network and the residual networks becomes possible. So if you see the quick code, first we are making an encoder input. That encoder input is now then this full input or this full layers are then now getting passed into my Keras model. And even this particular input is having multiple layers, which is a conv2d function. Then this is one model now, encoder model. Now again we are creating a layer, which is we are just reshaping the output of my encoder, which is again the input of this particular network, that is the decoder output. So we are trying to create a model which is known as an autoencoder, and if you see the code, we are passing keras.model, and what are the different parameters? First parameter is my encoder input, which is already a Keras model. Then was the decoder output, which is again a different Keras model, and we are giving the name as autoencoder, and then we are trying to see the summary. So functional APIs is nothing but it helps to define the complex models such as the acyclic graphs models, actually which is sharing multi-output models. So now we are having an idea what is a sequential API and a functional API. So these are the two main ways of composing the models. So now I think we are now pretty clear with the different terms, that is like what is a training set, what is a testing set, what is back propagation, what is forward pass, what is parameter, model parameter, and what is hyperparameter. So now we will be stitching all these data points or all these summaries and now create the different models. Along with that, I'll keep on sharing some of the concepts or the theories so that all are interrelated to each other. So please go through the video one by one. It will give you a proper flow of learning the things. And also please like and subscribe. Please share the video so as to help our channel. Thank you.